Are we ready? Okay. I'm not sure if people are having problems joining because I can't see many attendees.
Do you want to start, Kanachi?
Yeah. Hi, everyone. Good afternoon and welcome to today's webinar series. Today is the second day in our blockchain week. This is brought to you by the Glasgow University Engineering Technology Society, which I'm the president, and the society is just a way to bridge the link between the industry and the academia. So as well as to bridge the link between professionals and students. So what we do is we run a series of seminars from our top researchers at the University of Glasgow and sometimes from other universities. And then so that they can show students what they're actually working on. And then we'll do the same thing for the industry. So we'll bring in people from the industry to talk about their work, the latest technologies that they are working on, and how students might be able to get involved. Membership of the society is free. We're also the official branch of the IEEE at the University of Glasgow, and just about to get affiliated with the IET. So a lot of exciting things planned involved, and if you do wish to join, I'll be sharing the journey links and the link to our website. We're running this particular blockchain week in collaboration with the FinTech Society at the University of Glasgow, and I'm going to let the president, Shyam, say a few words about his society.
Thank you, Kanachi. Yes, so this event we are bringing to you with the Engineering Technology Society is about blockchain, a FinTech and technology event. The FinTech Society is mainly an education and community building society. We also try to facilitate connecting you to people in industry. But our main goal really is to build society and to encourage people to engage in the topic of FinTech. That being said, we are holding our yearly AGM this Friday. So I encourage every one of you to attend or even apply if you're interested in being part of this board next year. I'll give the word back to Kanachi, and we can start the event.
Okay, thank you. So today we have PolkaDot and W3 Foundation. So these are leaders when it comes to blockchain technology, and they have a range of applications of blockchain for industrial uses, and that's what they're here to talk about. So our speaker for today is Danny, and without further ado, I will let him introduce himself and tell us why we're here. Thank you, Danny.
Thank you so much. So it's a pleasure to be with you all today. I'm Danny. I'm a technical educator at the Web3 Foundation. I'm actually an undergraduate student. I'm in my final year of a computer engineering program at the Ryerson University in Toronto, Canada. So I'm also a student, and I recently started at the Web3 Foundation in the middle of March, so I'm relatively new. And like you folks, I'm also learning a lot of these things new and on my own, and obviously within the community. So many of the things that I've discussed, or rather we'll be discussing today, there's a lot I still need to do to better my knowledge about. And just like you might have some hesitations or some things that seem like buzzwords at first, but then when you sort of hear them over and over again, you start to really grasp the understanding and the concept behind it. And that's sort of how I feel like it's been for me. And I'm psyched to be giving this presentation to you. And hopefully at the end, if there's any questions, I'm able to answer them. But if there isn't, I'll definitely follow up and we'll get an answer and figure that out. So a bit about the Web3 Foundation. The Web3 Foundation basically has a mission to nurture cutting edge applications for decentralized web software protocols. And this is in hopes to create a web where users control their own data, identity, and destiny. So something that the Web3 houses is PolkaDot. What is PolkaDot? Formally speaking, PolkaDot is a heterogeneous multi-chain that connects and secures blockchains with pooled security and interoperability. So metaphorically speaking, you can sort of think of PolkaDot as the intersection between many other blockchains, sort of bringing together all these different types of blockchains and creating this web, this new web of an internet where there's decentralization. And the blockchain is really the core front of the control, where the control is taken away from centralized institutions and basically put in the blockchain, so no one really is in control and has an advantage over the other. So this is done in a trust-free way. And something I really like to refer to PolkaDot as, so if you think of the other blockchains that exist, you can sort of think of them as like major roads or highways. And then PolkaDot is sort of that interconnection between the highways, bringing everything together. And PolkaDot's philosophy as a protocol is that there shouldn't necessarily be a blockchain that tries to be great at everything or really control everything in the best way they can. PolkaDot's philosophy is that there will be many blockchains that do their own distinct things. Some might do the same thing as others, but really it's about bringing them together, having them communicate with each other in a trustless environment in a secure and decentralized way. So basically, sovereign chains can interact, communicate with each other in this centralized way. And in the PolkaDot world, these are called parachains. So we can get into a bit of why PolkaDot versus perhaps other things that are similar or other protocols that might be in the works. So one of the things is the interoperability, and this makes interaction between existing blockchains easier. Another thing is pooled security. So this enables easy and secure deployment of blockchains with new and interesting value propositions. Heterogeneous chains, so it allows decentralized application developers to leverage capabilities of multiple chains. And thought through governance, which evolves with the needs of token holders through governance. So in PolkaDot, the token holders, the native token of PolkaDot is DOT. Some of you might be familiar with. They really have a strong position in terms of governance and things that happen for the protocol. This is a popular graphic that sort of illustrates the PolkaDot network. And throughout the presentation, we'll be touching base on the major component of the network and the connected chains. You see that there are a bunch of what we'll consider to be right now entities on the outsides connected to what seems to be sort of the main component in the center of the network. And this is referred to as the relay chain. So the relay chain is the connector chain of PolkaDot, and that provides strong economic security and interoperability protocol. Then on the outskirts, so these sort of entities that we referenced, the pair chains or pair threads, are third-party chains that connect to PolkaDot for interoperability, scalability, and pooled security, which are the things that we sort of mentioned that PolkaDot is inherent to. So if we break this down, if you sort of take one entity, which is a parachain, and we sort of break it down, you can see that there's the relay chain, and then validator, the core parachain itself, correlator, and a block. So hopefully that sort of breaks down one of those parachains, and we're gonna try to go through these at a high level at the very least. So the relay chain, like we mentioned, secures parachains and basically relays messages between them. Validators are staked full nodes of relay chain that are responsible for verifying and adding blocks to the relay chain. So validators basically manage relay chain block authorship. They parachain candidate agreements, they steward availability of external data, and the validators for doing this work are rewarded through a staking token expansion. So let's sort of put this into perspective and illustrate it. Let's say you wanted to be a validator. You would have some equipment, you would set up your machine and you would issue your intention. So the public can use, the public can use the system by interacting with state machines that they are interested in via the internet. Each state machine can provide different functionalities and behave in different ways. So we'll have a different state and state transition scheme. So to put this into perspective, the Genesis block of PolkaDot, so this is like the first block you can say, the starting point, was launched on May 26, 2020 as a proof of authority network, which essentially means that the governance is controlled by a single pseudo entity, so like a super user account, just to begin with. And during that time, validators that wanted to join the network were signaling their intention to participate in the consensus. So you have some sort of intent, like in this illustration, the intents sort of showcase as validation, setting keys, bonding, things like that. And then as a validator, you would wait for the next election at the end of an era. So an era is basically a period of time. In PolkaDot, it's 24 hours. So the validators are paid in proportion to the amount of era points that they have, where era points are essentially reward points. They can be earned for payable actions like issuing fidelity statements for parachain blocks. Then next up, you'll notice the validators that are sort of next in line are in this hierarchy based on the amount of token they have staked. And this sort of shows like the traditional proof of stake approach, where the validators with the most stakes sort of have an advantage in the network over the other validators. And that's sort of the impression that most people that are introduced to proof of stake consensus are introduced to. And this sort of comes from like the Ethereum mechanism. And through the presentation, we'll see that PolkaDot sort of revised the proof of stake mechanism to provide a more fair approach. And it's something referred to as nominated proof of stake. So you'll notice that the next in line wasn't necessarily validated with like 100 dot and then 50 dot. There was something that happened, some vote essentially, some nomination where certain validators were chosen to be next up. And we'll touch base on nominated proof of stake soon. Parachains and parathreads. So we touched on this a bit in the beginning, but parachains are parallelizable blockchains, really, parachains that make PolkaDot a network. So if we are considering them to be parallelizable, that essentially means that things are going on in parallel. So let's say transactions are taking place, right? These transactions are happening in parallel, which is a huge advantage, especially if PolkaDot's protocol is proposing that it be the interconnection to provide things like interoperability and communication through blockchains, made in a way where things can happen in parallel and there's not sort of this scheme or queue where you have to wait for certain things to take place and then you can do what you need to do. And this is also achieved because parachains have a unique implementation with their own runtime logic. And the major difference between a parathread is that it is also a parachain, but it does not stay connected to the relay chain sort of indefinitely, but rather on a per block basis to be included. So this is similar to like a pay-as-you-go service. And if that's the approach that the parachain would like to take, it becomes a parathread. Correlators correlate transactions on the parachain. They monitor into blocks and send a proof of this block to validators. So this is an overview of the system. a bit more zoomed in from the graphic we initially saw. You can see all the different components being outlined. We can see one parachain and how it's broken down, and hopefully we have a bit of a high-level understanding of each of the components, and we can use an example to try and understand, let's say, how a transaction takes place and how things sort of connect together. So if we take the case for one parachain, there would be a start of a new block candidate where there's a block creation time. So within that block creation time, which is a finite amount of time, there are transactions being added from a pool of transactions to basically create a candidate block. So in traditional blockchains, you can think of the correlator, the position a correlator takes, sort of the same as where a miner would be or where other validators would be, if we're not specific to PolkaDot, but for other chains that use like proof of stake mechanism, for instance. So the correlator would be at the end of that process, aggregating those transactions. The correlator then signs the parachain block candidate and produces what's called state transition proofs, which are basically a summary of the final account balances caused by the transactions in the candidate block. The correlator then passes on the candidate block and state transition proofs to the validators. The validators that are staking with DOT token then verify the transactions within the parachain candidate block. All as well, the validators will share that candidate block with the relay chain, so the main chain. The parachain candidates from all the parachains are collected together, and a relay chain block candidate is produced. This is now a candidate from the relay chain. Then the validators on the network that are connected to the relay chain will try and reach a consensus on the relay chain block candidate. And if all that goes well, if that consensus is validated, the now validated relay chain candidate block is shared with the validators and the correlators that are on the network. So basically the parachains that are connected. And this process repeats itself for new transactions. Great. So we touched a bit on the nominated proof of stake, and we can now probably formalize this into a better definition. So PolkaDot is secured by the economic power of the DOT token itself. There is no mining, so to speak. So this is via a consensus of proof of work, which some of you might be familiar with from blockchains like Bitcoin, but rather block production from the set of most highest stake validators. So that is, if you wish to produce blocks, you and your nominators must bond enough stake DOT tokens to get into the top sort of slots. So this is basically, in a way, trying to say that you're trying to be one of the best validators. So you would get into the top N slots. And then at that point, if that's a success, your validator will receive approximately equal amount of DOT tokens as any other validator. And this is sort of where the nomination comes in and how there's an attempt to provide more fairness on the network. So the issue with like the rich get richer validators that are staked more than other ones isn't something that's prominent on the network. So in the perspective of nomination, can validate with minimal owned stake. Nominators punished along with validators for infractions, the same way other validators would be punished on other networks. So if, let's say, you're offline or you're trying to cheat, or there's something that is just not standard to what the validator nominator should be doing, then there are consequences. Usually that's referred to as slashing, but that still applies if you're a validator. Yeah. And all validators share essentially equal rewards as long as they are in the active set. Why be a parachain? Well, we briefly went over a few of these concepts, and we can try and categorize them a bit better. So one major thing is that there's shared security, and essentially any chain connected to the relay chain shares the security of all chains in the network. So verification and finalization of blocks is performed by all the validators on the relay chain, which is obviously a huge advantage because of that enhanced security. Then there is something called Xcmp, which stands for cross-chain message passing. And this is really the mechanism for messaging communication on the network. So this guarantees the delivery of messages between parachains and parathreads. So cross-chain transactions are resolved using a simple queuing mechanism to ensure fidelity. It is the task of the relay chain validators to move transactions on the output queue of one parachain into the input queue of the destination parachain. But only the associated metadata is stored as a hash in the relay chain storage. So the Xcmp will not push messages on the relay chain. It only a hash for each inbound and output queue. So hopefully there's this layer of knowledge being built on parachains, at least at a high level, and you might understand the inter components of a parachain. Obviously, there's a process to become a parachain on the network, which when a chain or a blockchain would like to become a parachain, there's a process that needs to be followed, starting with parachain auctions. So every 2 weeks, a new slot will open up for parachains. A candle auction, which is an auction where the exact end time is unknown, and in our case is determined retroactively, is held. There are dots that are locked for that period of time by the system itself, and that dot is not really sent anywhere. They remain in the user's account, but they're non-transferable and non-stakeable. So that's sort of the compromise that is made where you're giving up a certain amount of dot tokens for that auction. And there's a crowd loan functionality. So in order to compete for a parachain slot, projects can have dot holders lock the dot on behalf of the parachain. And this is all done in an automated and trustless way. The parachain runtime handles this. So slot length is where parachain slots last up to 2 years, biddable and 6-month slots. After a slot would, let's say a slot expires, you can then become a parathread. So if you have a slot expire while being a parachain, you can transform into a parathread, which will then be the pay-as-you-go schema that we referenced. So the common misconception is that you must win a parachain slot to run a project on PolkaDot. And this is only true for parachains and parathreads. So really just putting that into perspective, that's true for fully functional chains themselves. But there are projects that can run on top of parachains, and it's not really necessary to have a full-on parachain slot for that project itself. And these projects are most well-suited towards running as smart contracts rather than a parachain. So essentially using the parachain as a foundation to run their decentralized application as smart contracts. We'll touch a little bit on the consensus, and we've been referencing this with the sort of validation process, the way transactions take place, and this is done through a consensus mechanism that's often referred to as hybrid consensus. So in modern blockchains, there's always a scheme for finality, which in classical blockchain models is probabilistic. And there's other mechanisms such as tendermint, which I believe is the mechanism that Tezos uses, have provable finality. So to distinguish these two, probabilistic finality means that under some assumption about the network and its participants, if we see a few blocks building on a given block, we can sort of estimate the probability that it is final. So it's like in a sense, a speculation with certain things in place for that assumption to be valid, of course. Whereas provable finality, we have this notion of irreversible consensus. And the big drawback is that they are vulnerable to stalling. And then let's say PolkaDot may occasionally need to revert blocks that have been recently added in case of conflicting information about pair chains. So this should be rare, and the ideal situation is where we generally have fast finalization, but block production can continue, and we let finalization sort of catch up when it's ready. So this may be leading into a solution or an approach, or rather a mechanism that takes the best of both worlds and uses them accordingly based on the status and the state of the network at that point in time. And this is referred to as hybrid consensus. So finalization is done via a separate finalization gadget, and block production can always continue as long as one validator is online. So in ideal circumstances, block finalization can be rather fast. So a few blocks empirically, 20 to 30 seconds on our canary network, Kusama. We'll touch base on Kusama a bit at the end. But Kusama is often referred to as the cousin network of PolkaDot, and everything that we're going over here more or less applies to the way Kusama is structured. And then with minor issues, you can delay finalization while further checks are done. And then let's say in the event of severe network partitioning or something like a malicious attack, block production can continue, but we temporarily fall back to the probabilistic finalization. So then that's where the assumption schema comes into play for temporarily, because the network at that point in time would benefit from having probabilistic finalization instead of formally finalizing the block and where the consensus can't be reversed. And really, this is a protocol that can be split up into two parts. So these have popular acronyms called BABE and GRAMPA. And BABE stands for Blind Assignment for Blockchain Extensions. So validators randomly select themselves to produce blocks. The BABE is essentially the block production mechanism that runs between the validator nodes and determines the authors of new blocks. But the benefit of BABE is that it assigns block production slots to validators according to, it assigns block production slots to validators according to stake while using the PolkaDot randomness cycle. And that's basically a way to provide fair and unpredictable distribution of validator responsibilities. Then just at a high level, GRAMPA, which stands for Ghost-Based Recursive Ancestor Deriving Prefix Agreement, is the finality gadget that we mentioned in the previous slide that is implemented for the relay chain. And to sort of illustrate these two things, on the left-hand side here, we have blocks produced by BABE, which are not yet finalized. So again, this is the block production method. And then up until GRAMPA to that point in time, those are the blocks that have been finalized. A little bit about PolkaDot governance. PolkaDot nodes run software, which in turn run a blob of WebAssembly bytecode. And this bytecode is stored on-chain and is modifiable through the system itself. This means that many parameters up to and including the actual code of the core relay chain state transit function can be updated. And governance obviously determines how we allow that to happen. So you can imagine in a real life situation or scenario where there's this authority and governance. It's, most governments and most either institutional governments, corporate governments, what have you, are quite centralized, and there's this authority attribute attached to them. Obviously, if the goal is to build a decentralized web with protocols that are constantly improving. The key in that is that the users on the network that hold the token should have a lot to do with the governance to drive that decentralization narrative forward. And these are really the goals of PolkaDot's governance, and its robustness and its ability to provide that desire to have decentralization at its best and to continuously improve protocols that are decentralized. So, of course, the ability to make good decisions, and this comes with fair representation and the ability to decide despite limited voter attention to things like low turnout or even high friction. And of course, security, so avoiding loopholes and unintended behavior, or someone trying to sort of mess with the governance in a unethical way or interrupt things that are happening with on-chain governance. And then coherence, so the ability to keep the community united and to avoid forks, which if you're a bit familiar with the space, is often a problem with some of the other traditional blockchains where there isn't coherence inherent in the governance and there's consensus issues. So some of, let's say, the developers will fork the project and implement their approach, sort of dividing the community and really giving the what could have been a very solid project a bit of a hit in terms of the strength for those behind the network and those developing the network and maintaining it. And then scalability, so the ability of the governance mechanism to allow many participants to consider many proposals. And preserving decentralized qualities, of course, which is really where these goals may come together. No party should be privileged over another priority or another party. So all changes to the protocol must be agreed upon by stake-weighted referendum. The majority of stake can always command the network. This is a bit about the architecture from a human sort of perspective, the way things are governed in PolkaDot. So there's a council. The council is an elected body of on-chain accounts that are intended to represent the passive stakeholders of PolkaDot and our Kusama. The council really has two major tasks in governance. One is proposing referenda on behalf of the passive stakeholders, and then vetoing dangerous or malicious referenda based on the severity or state of that referenda that's being proposed. So with PolkaDot, there are 13 members, and then Kusama, like we mentioned, the cousin network of PolkaDot, 19 members, and these are elected by the dot holder, in the case of PolkaDot, and Kusama, the native token is KSM, so it would be KSM holders rather for the Kusama network. There's a technical committee, which, to keep it short and sweet, is generally composed of engineers developing away. And really the ultimate power, like we mentioned, rests in the hands of the dot holders. And this would be the desire if you were to sort of consider what the goal of the network seeks to be. However, governance is hierarchical from global to more local levels, and only proposals with sufficient support are tabled and debated. So there's a level of support that needs to be reached for a proposal to really get noticed, to be something that requires debate, discussion, and conversation. Dot holders elect the council to table and evaluate proposals, really. So intuitively speaking, non-controversial proposals are easily approved or denied, whereas controversial proposals require significant general approval to pass. And the approved proposals are enforced by the decentralized protocol. So there's no central party involved, which is great. Substrate. So Substrate is really a framework to efficiently build different blockchains and really make blockchain development easy. So you can sort of think of Substrate as like a set of libraries and functions that are built into a framework, or collected into a framework rather, that take care of much of the nitty-gritty of blockchain development, and allows you to focus more corely on your development or the key components of your, let's say, decentralized application or the application you're trying to develop, with the added flexibility to add and drop certain functionalities you may place. So the image shows this block type of like a Lego where you can sort of connect and also take off things as you would need for your blockchain development. And to be honest, I would definitely recommend looking at some of the Substrates tutorials. I can also link them over that are offered by PolkaDot, and trying to build something for yourself, or even just to sort of get a network started, just to get a grasp of how things look and are structured. And then Kusama. So like I mentioned, the things that we talked about in terms of PolkaDot's architecture and the way things work are generally the same for Kusama. And Kusama is often referred to as PolkaDot's canary network, or what I said initially, which was PolkaDot's cousin. So Kusama is also similar to PolkaDot in the sense that it has the parachain approach, and the fundamental differences come in the focus, where Kusama is more focused on early stage startup networks with radical development approaches, or even transitions. So if I have a centralized application, so to speak, and I want to bring it into the decentralized world, I can, in a sense, radically transition that first on Kusama, and then hopefully eventually when things are settled and decided upon and things are structured in a way that's agreed upon between the developers, you can transition to PolkaDot to make that more mainstream or definite. And there is often a misconception that Kusama is just a test net. It's true that it's supposed to serve as like a pre-production environment, but it's really where key transitions and development can happen and where things can be discovered. And the future goal of Kusama will basically be what any other blockchain that wants to be a parachain will be. So Kusama will also be a parachain on the PolkaDot network eventually. And that completes our little intro to PolkaDot. I'm Danny again, for anyone that missed in the beginning. I am a technical educator at the Web3 Foundation. This is some of my contact information. Below that are some links to certain guides and tutorials and things that basically represent the PolkaDot network and the Web3 Foundation on the web, and I definitely recommend checking them out. But if there's any questions, we can certainly look at those and go from there.
Thank you very much, Danny. Before the questions, we're going to have Arena from the Web3 Foundation say a few words while we collect the questions. Jeremy is going to handle the Q&A. Arena, whenever you're ready. Do you need to share your screen?
Yes, please. Hi, everyone. I'm not actually from Web3 Foundation. I'm ambassador of PolkaDot. So I'm going to just present very briefly ambassador program and talk about some of the ecosystem projects. And also I'm going to announce a little contest from one of our ecosystem projects. So my name is Irina Karagava. I'm head ambassador for Western Europe community at PolkaDot and Kusama networks. You can reach out to me on LinkedIn. This is also a link to our ambassador program. Anybody can get involved, really, regardless your background. You can be a developer, technical, not technical. We have several working groups for developers, for translations, for events. So please join our official social media or reach out to me for more information on that. So there is common sort of misunderstanding what PolkaDot is. So PolkaDot is a network protocol. It is not a company. And companies behind PolkaDot are Web3 Foundation that mainly runs the treasury and all the research efforts, and Parity Technologies, a blockchain development company that runs the tech part. So how can you get involved? You can become a validator on PolkaDot. You can apply for Web3 Foundation grant for building your application on PolkaDot network, or you can join ambassador program and network with community and sort of get involved also with the ecosystem projects. So some of our ecosystem projects include a Kala network, which is a DeFi hub on PolkaDot, Robonomics network, which is an Internet of Things application for smart cities and robotics on blockchain. Zagist, an evolving blockchain for prediction markets. Subsocial network, which is the open platform for decentralized social networks and marketplaces. Unique network, which is an NFT chain for Kusama and Polkadot. And Darwinia, a decentralized cross-chain bridge network building on Substrate. These are only a few, but there are over 300 projects currently being built on Polkadot. So you can follow also ecosystem projects as well as for like different to understand better different use cases. Darwinia is a good example of bridges. Subsocial, for instance, social network. So today I would like to introduce a little challenge, contest from Subsocial Network. I'd like you to head to app.subsocial.network and tell us, how do you see the future of Web3? What can be created on Polkadot that cannot be created on other networks? And how do you see the potential of Web3 social networks? So what can be done in social media in Web3 that cannot be done on Web2? And please use the tag UofG Polka Vision so we can track your comments. And we then will choose with Alex Seaman, the CEO of Subsocial, the best responses, and we'll give out some Polkadot swag. So yeah, this is it for me today. If you have any questions, as I said, please feel free to reach out on social media. And thank you everyone for joining.
Thank you, Irina, and sorry about my mistake earlier. Jeremy, if anyone has posted any questions, could you just get them together and ask Danny? They also shared their contact details. So if there are any questions that we're not able to take today, or if you have any questions going forward, you can always reach us and we'll pass them on. Jeremy, over to you.
Okay. I'm just trying to view the question as something broke here.
Mate, just in case anyone who's watching via the streaming has questions, so keep an eye on that.
So we have one question from Malik. Do you have any current adopters of PolkaDot? That's to Danny. Do you have any current adopters of PolkaDot? That's a question from Malik. So
Sorry, I just couldn't hear the question properly.
okay, Malik asked, do you have any current adopters of PolkaDot?
Current adopters?
I guess maybe what he means is if there are any companies currently using this technology right now or something.
Oh, so basically like I'd assume like mainstream companies or like big tech giants. Yeah. Is that fair to say?
Yeah, so maybe we could just give a general answer.
From my understanding, not at the moment, or I'd hope to say not yet, but perhaps there's companies that I'm not familiar with that are using PolkaDot, but sort of the mainstream big tech giants, I don't think any of them are using PolkaDot right now. What I do know is a lot of the big tech companies are focusing a lot with blockchain outreach, some research and development. Not all of them comparable to the other, but there's a lot of things from the big tech giants perspective that they need to consider. Obviously, if there's this proposal for, let's say, Web3 not being really the version of Web3 that big tech sort of has going on right now. So put that in perspective, let's say when we all started school, when I started school at least, the impression was that the new web would really be this sort of web where everything has an IP address and it all links back to some centralized source of control. And when I first thought of Web3, I would think of things like Google Home, Amazon Alexa, things like that, and obviously AI and machine learning. And blockchain was also part of that, but that's usually the narrative, that the narrative of decentralization isn't usually pushed. So I would assume from a big tech giant's perspective, if they were to adapt to PolkaDot, it would more or less be for self-interest, or else the hierarchy and the centralization that some of these tech companies have right now would basically be given back to developers, users, end users, things like that.
Okay, we have another question from anonymous attendee. Where do you see PolkaDot going in few years? And how soon can we expect the technology to become available to users?
So I just didn't get the last part of the question.
How soon can we expect the technology to become available to users?
So the technology right now, you can build on PolkaDot. It's available to use. There's a lot of projects going on that was just mentioned by Irina. Like these are basically projects that are candidates to be parachains, and there's obviously ongoing development on PolkaDot, but there's no real restriction to build on PolkaDot. Where would I see it going in 2 years? Well, I think I can speak on behalf of the entire space. So you might often hear in the space of a lot of blockchains coming out after Ethereum that sought to be like the Ethereum killer or hope that they're the better version of Ethereum. Whereas PolkaDot isn't really focused on killing another blockchain or being the best. PolkaDot wants to really drive the whole space forward while connecting everyone together. And from what I'm seeing is that development is happening very, very rapidly. Like I'm obviously new to this space. There's, like I mentioned, a lot I still have to learn. But even for people that are experienced, I feel like the space moves faster than what you can learn at a given time. So I really see PolkaDot being talked about a bit more, at least mainstream, and it being more of a comfort environment for developers to go to, at the very least.
What is kind of average power consumption that would be required to use the PolkaDot? Could it be implemented in like low power embedded systems or in terms of unit application, or do we need big PCs and applications effectively use?
Sorry.
Jeremy, I think your audio is a bit spotty. So if you could maybe repeat the question, I'm not sure Danny got it. But from what I heard, parts of the question I heard, he was trying to ask if PolkaDot, the power consumption for PolkaDot, and if you can run it on like, I think embedded processors, or if you require like lots of computing power to run the application. Jeremy, could you repeat the question if you don't mind? I think he's trying to type. Okay. Yeah, so. Can you see the question, Danny? Yeah.
So from my understanding, and I sort of also know this from a high level, I could definitely follow up and give like a much better detailed response, but PolkaDot tries to solve a lot of the issues with traditional blockchains. One of them being scalability, which is quite often mentioned as a restriction for Ethereum. Another one is power consumption. So there's sort of a debate, obviously, with people that are followers and fans of Bitcoin, that power consumption is an issue. But really, if you think about living in a vacuum, the less and less and less electricity use is obviously preferable, even if you're claiming that you might be consuming a bit power, you're not really consuming a lot of power. So the mining process traditionally in some of the blockchains are power heavy and use a lot of power consumption. And obviously with things like Bitcoin, you can't really run it on any piece of hardware. It has to be a specific type of hardware. And PolkaDot, from my understanding, it should be able to work on low power embedded systems. You might not be able to run like fully fledged aspects of the network, but at the very least you can participate from basically devices you'd have at home. And that's really the approach, to make a more fair environment, so not only people with like the most amount of money who can go out and purchase the high-end equipment can participate in the network.
Okay.
Jeremy, do you have any other questions?
Those are all of the questions we had so far. There's nothing on the YouTube.
I wanted to type a question, but I think I could just ask you, Danny, just about your own journey and what kind of opportunities are currently available. So maybe just if you could share a bit of the story of how you got in to PolkaDot, especially as a student. So if there are any other internship opportunities, I mean, apart from the ones that Arena has announced, I think someone else wants to ask a question when you're done.
Yeah, for sure. It's a good question too. So like I mentioned, I'm still a student. I'm in my final year, but obviously, finishing school, there's this next step narrative that's roaming in your head, like what to do next, and you have to find work and things like that. But throughout my undergraduate degree experience, I've had the opportunity to do some work in the industry through like student internships and co-ops, and this was really a lot of corporate level stuff, and I definitely learned a lot. I met some very talented people, very great, like nice people, but I had a sense of guilt inside me because it wasn't really me, and it didn't really coincide with, I guess you could say, like my belief system in a way, or just how I saw computer engineering being applied in the future, and like what innovation really meant to me. So I took a step back and I really had a high level interest for blockchain and things like that, but I wanted to make that formal. I wanted to learn a lot more on my own, and I started to do that in more recent times. And I started to learn about the major projects and things that are inherent to those projects, and why one protocol works a certain way, or what's the difference between this and that protocol. And for the case of PolkaDot, like what PolkaDot trying to accomplish, what the Web3 Foundation is. And from there, really my interest sparked, and I was sort of sold on the whole mission of the foundation. And I found an opportunity as a technical educator, and we went from there. And I'm happy to be part of the foundation, and hopefully in the future I can contribute much more when there's less priorities, being a student, and some other priorities. But I know the event is being partially run by IEEE. I used to be part of the student branch of my university at IEEE, so I kind of have that connection. And something I wish we would have done more is what you folks are doing now, which is awesome, and that's really bringing in like the industry type of knowledge, and combining that in a way with maybe things you've learned in your courses and the academia. So sort of bridging that gap, but specifically to like blockchain and things like that, I think that's awesome.
Okay, thank you, Danny. So the other question I have just before you address Victor's question is the whole idea of decentralized systems and serverless systems. The one of the reasons that the current systems you have works is because of people get paid. So how do you see the sustainability in decentralized systems, and what's the incentive for anyone who wants to maybe offer their computing power or whatever infrastructure they are so how's the infrastructure going to be maintained?
Right, yeah. So if you take the case of any blockchain, let's say, you can participate in a network, and that obviously drives the network forward. So a network really is only as good as the people backing it, and that goes from maintenance, development, the governance. And with the way most blockchain architectures are structured today, there's some mechanism, some schema that provides incentives to the participants on the network. So let's say if you're not really physically contributing to the network, but you're just like a stakeholder, or you just have an investment in DOT. For PolkaDot's case, you have an investment in DOT token. You still have things you can do with governance and things like that. But then if you want to contribute more and do things like validation or nomination, or even contribute to the open source development, there's incentive structures that are built in to incentivize developers and users in that manner. I'm not sure if that answered your question.
Yeah, I think it does, kind of. All right, thank you. So I think the other question was from Victor, was about where you see the future for PolkaDot. I think we've already addressed that. So Jeremy, over to you.
Okay, so thank you everybody for coming. And just to introduce myself quickly, I'm the event coordinator for the Xcmp series, and I'm from the Engineering Technology Society. We'll have another 2 talks this week on the same time, one tomorrow from Smart Key, and another day after that from Local. Basically, the Smart Key talk will be talking about use of the product, which is basically a blockchain application to use in car locks, and as well as some what they call smart cities. It's being used by emergency services in Poland. It might be interesting for some engineers. And the if local talk will be more about NFTs and less technical applications of the blockchain. But my interest some more arty people. So thank you all for coming again, and that will be it for today. The recording of the event will be available on the YouTube channel of the FinTech Society, which is linked in the event description on Facebook. So,
okay, just to thank our speaker, thank you very much, Danny, and thank you, Arina. We'll be following up on the opportunities you announced in case our members are interested. So thank you everyone for attending. I don't know if Shyam has any final words.
Yes, I'd like to thank PolkaDot as well and Web3 for coming and introducing themselves, talking about their solutions, blockchain solutions. And as Jeremy, I'd like to encourage everyone to attend tomorrow and on Wednesday. And then once all of the talks are over in the Blockchain Technology Week, we'll post all of the events, the recordings of the events on Facebook for everyone to see. So thank you.
All right, thank you everyone.
Great. Thank you for having us.
Yeah, see you guys tomorrow, hopefully.